Hello, my name is Stan Trauth. I'm presenting today on the distal excurrent ducts and penile morphology of the urogenital system of the Mississippi mud turtle. I am co-authoring this presentation with Mike Plummer, who provided several specimens in order to do this work. Figure 1 shows the urogenital system of the male turtle extracted, and you can see gross morphological features including the testes, the kidneys, the epididymides, the excurrent ducts, which I'll be talking about, the urinary bladder, the retractor penis muscle, the penis, the corpus fibrosum of the base of the penis, and then the penis proper here with the tip of the penis called the glans penis. The first photomicrograph identifies all of these, or most of these, urogenital structures, including the testes, the kidneys. Here's some dorsal musculature, but also the terminal portion of the digestive tract called the copperdium. So I'll be pointing out the copperdium in the next few slides. The copperdium in figure 3 here has many folds within it, and that'll be obvious when I show cross sections of this region. But the focus of this portion of the study now is really these distal excurrent ducts. We can find the ureter or ureter and the ductus deferens together here. So this is my focus area of the excurrent duct portion of this study. So in a series of cross-section or transfer sections of the region, now we begin with the kidneys here, and then the ureters on either side, and they're still closely attached to the kidneys. You can also see the ductus deferens on both sides, and both sides are full of sperm. The section in B now shows that the ureters have moved away from the kidneys and are now associated with the ductus deferens. And coming available to be seen now is the copperdium. And if we look in C, we can see that the copperdium has all these folds, which I had mentioned earlier. And as a diagnostic of the copperdium is the muscularis externa. Muscularis externa. Now the ureter and the ductus deferens closely associated with one another, and that'll be obvious in the next few slides. So here's a continuation of figure 4, and we have here the copperdium and all the many folds here. The ureter, very evident, and then the ductus deferens, quite evident also. And these are going to be moving more medial, and they are going to dump into the urogenital sinus through the urogenital papillae, which are shown in B. So the urogenital papillae are evident, and then these ducts are also evident within the urogenital papillae. Now, if you go on to C, you can see that the ductus deferens on one side at least has dumped into or has merged with the urogenital sinus. And then the ureter is also present on both sides. And this is better shown in the next slide, where you have the ureter extending all the way through the urogenital papilla. And it dumps into the urogenital sinus posteriorly compared to the ductus deferens on both sides. In B, we see that the urogenital sinus now is not as expanded, it's becoming more contracted. The urogenital papillae are just about to leave or be lost. But also up here we can find the coprodium again with the well-defined muscularis externa. In C, the urogenital sinus now has merged with the what is now termed the urodeum. So after leaving the coprodium, we now have the urodeum because of the urogenital sinus merging with this portion of the cloaca. The muscularis externa weakly defined in the urodeum, and you can compare it with the muscularis externa present in the coprodium. The next slide shows comparison of those layers of the muscularis within the coprodium. You have a longitudinal layer and a circular layer. And also shown in this figure are the epithelia of both the ureter and the ductus deferens. In B is the ureter, and it is lined with transitional epithelium, as one might guess. It does expand, and over here in C is the ductus deferens, full of sperm, and its epithelium is a pseudostratified columnar epithelium. I'll back up to A for just a moment. The coprodium has a lining of columnar epithelium, tall columnar epithelium, but I can also point out some of the goblet cells that are present, defining the this terminal portion of the digestive tract. So this is the distal excurrent duct, excuse me, portion of this presentation. I move on now to the penile morphology. And we start out at the base of the penis with the base of the penile proper being the corpus fibrosum, which I pointed out in the first figure. And then dorsally, you have the corpus spongiosum. The corpus fibrosum will remain throughout the entire length of the penis, even though it becomes smaller, but it is present. The spongiosum is going to elaborate into structures which I'll point out. They are going to be folds, which have special names. SR is the seminal ridge, which is a continuous structure of the connecting the corpus spongiosum on both sides. And here is a seminal groove, and the groove will be important as we move on to the next few sections. What we find in B here is an anterior extension of the seminal groove, and it is termed the anterior sinus of the seminal groove. This is a new structure which I discovered was not present in other descriptions of kinosternid turtles. Now we can also see it here expanding and getting larger. Also, by the time we're in D here, we can see that the corpus spongiosum has become much reduced, and the corpus fibrosum is now bilobed, clearly bilobed. So here we have this anterior sinus still, anterior medial sinus of the seminal groove. As we begin to get into the glans penis, we see an elaboration of the morphology of the dorsal portions, excuse me, of of the penis. Many sinuses are present, like this particular sinus here, which is the anterior sinus of the seminal groove on top of the ridge, seminal ridge. The groove is still present. See it there and up here. As we move more posteriorly, though, we find that the the corpus spongiosum, and now becomes elaborated into what is this fold called the plicae externa. On both sides, these folds become quite large and folded, as we'll see in the next section, or next slide. But in the before we get there, we can see that this anterior sinus of the seminal groove penetrates anteriorly. Now this particular sinus is going to enlarge and merge actually with portions of the sinuses of the seminal groove. Here again, we can see the plicae externa. The corpus fibrosum has become smaller, but still it's a basal plate. And finally, the last slide in this series shows the development of the plicae externa, quite large in nature. Also, medially and into the B portion here, you can see that the plicae media are evident, and they in fact merge with the plicae externa, but as you go posteriorly, they separate, and what you have then is an extension of the seminal groove going into the plicae externa, as well as the middle portion of the plicae media. So these medial folds are much smaller than these more lateral and dorsal folds. By the time you get to the end point of the penis, the terminal region, we find the structure called the dorsomedial triangular fold, and it has a sinus in it. It is an extension of the seminal groove sinus. But on the other side, on either side, and I didn't point that out here, is the posterior portion of the seminal groove. So what we find is more of an elaboration of the folds of the penis as you go posteriorly, and the sinuses or spaces will become well established and enlarged. Of course, when you see this penis extended, these folds would be more spread out and not as squeezed together as shown here. But it's easier to section, I will say, when the folds are closer together. So that really concludes my presentation. I will point out that additional penile morphology and turtle studies, at least histological studies, are going to be a challenge, especially, for example, in the spiny softshell turtle, where you have a penis which is tremendously long and difficult to section in the relaxed state. And that concludes my presentation.